In this video, we're going to look at probability. Now, the probability of an event lies between 1 and 0. So a probability of 1 means that the event will happen, and a probability of 0 means that the event will not happen. So if you think about it, between 0 and 1 would be fractions. So the closer you are to 1 is the more likely an event will take place, and the closer you are to 0 is the more likely that an event will not take place. So anytime you're working out probability and you get an answer that's not between 0 and 1, you know you did something wrong and you need to check over your work. So here we have our formula for probability. The probability of an event is equal to the number of favorable outcomes over the number of total possible outcomes. Now I'll give an example how to use this formula. So here I have my question. A bag has 4 red marbles and 6 green marbles. If a marble is chosen at random from the bag, what is the probability that A, the marble is a red marble, and B, the marble is a green marble? So first, let's look at A. The probability that if we choose a marble at random from the bag, that the marble is a red marble. So first, we'll need our number of total possible outcomes, which we call our sample space. So you ask yourself, how many marbles are there in the bag? Well, we have 4 red marbles and 6 green marbles. So there are 10 marbles in all. So the bag contains 10 marbles in total. So I'm going to write that my number of total possible outcomes is equal to 10. So I have my number of total possible outcomes is equal to the 4 red marbles plus the 6 green marbles. So I have 10 marbles in all. Now, as I said, we also call that the sample space. So I can use n as the number of elements in a set, and my set is the sample space here, is equal to 10 marbles. So this is just a short way of writing the number of total possible outcomes. Number of elements that's in the sample space, and the sample space is a set. Now, let's look at the number of favorable outcomes. So for part A, we want the probability of getting a red marble. So we want the number of red marbles, which is 4. So for part A, the number of favorable outcomes is equal to 4. Now, if we use R to represent the set of red marbles, I can simply use the number of elements in a set of red marbles is equal to 4. And this will be a shorter way of writing out this. And instead of writing out the probability of getting a red marble, I can simply write P and in brackets R, and this would mean the probability of getting a red marble. And this would be equal to the number of elements in a set of red marbles over the number of elements in the sample space. And that would be equal to 4 over 10. And if you break that down, you'll get 2 over 5. So if you were to randomly choose one marble from this bag, the probability of getting a red marble would be 2 over 5, or 2 out of 5. You could also write this 2/5 as a decimal. So you can simply go on a calculator and press 2 divided by 5, and we just convert that to a decimal and get 0.4. So this is equal to 0.4. So now you see how easy it is to work out the probability of an event. So for part B, the probability of getting a green marble, if a marble is chosen at random from the bag, would be the number of green marbles, which is 6, divided by your total possible outcomes, which is 10. So that'll be 6 over 10. You break it down, you get 3 over 5. So let's come across here and work out part B. So for part B, I'll put the number of elements in my sample space, which is my total possible outcomes, is equal to 10. I'll put the 4 plus 6, which is equal to 10 marbles. I'll put the number of elements in a set of green marbles, and use G for green, is equal to 6. And now the probability of getting a green marble, so I use P with G in brackets, meaning the probability of getting a green marble, is equal to the number of green marbles over the number of elements in the sample space. So that'll be 6 over 10, which is equal to 3 over 5. And as a decimal, 3 divided by 5 is equal to 0.6. Now let's look at something here. We only have two types of marbles in this bag, red marbles and green marbles. So the probability of not getting a red marble would be the probability of getting a green marble. Because if you didn't pick a red marble, you'll be getting a green marble. So I'll put the probability of not getting a red marble is equal to 1 take away the probability of getting a red marble. I can write this not getting a red marble as P R complement. All right, so this means not R. When you put the complement on the R, not R, so not red. So this is equal to 1 minus probability of getting a red marble, which is 1 take away. And if you go back here, we can see the probability of getting a red marble is 2/5 or 0.4. So the probability of getting a red marble is 2/5. So if you look at this 1 here and this denominator 5, then this 1 is 5 over 5. So then you have 5 take away 2, which is 3. So the answer will be 3/5. Probability of not getting a red marble is 3/5. Or we can use the calculator and say 1 take away 2 over 5 and see that our answer here is 3/5. So if you look at it, the probability of not getting a red marble is equal to the same thing as the probability of getting a green marble. Because look up here, the probability of getting a green marble is 3/5. So the probability of not getting a red marble, so the R complement for not R, is equal to the probability of getting a green marble in this question. So here I have a table with some marks and I have some group data here. I worked out the cumulative frequency already. And I'll put a link in the description where I worked out this cumulative frequency and drew the cumulative frequency curve, because we are going to use the cumulative frequency curve here. So let's say I wanted to know the probability of a student getting above 75 marks. It'd be kind of hard to estimate that from here watching this table. So here I wrote out that question, find the probability of a student getting more than or equal to 75 marks. So what we're going to do is draw the cumulative frequency curve. So here I have my cumulative frequency curve for the information on this table, cumulative frequency on the y-axis and marks on the x-axis. So this frequency is the number of students. So the cumulative frequency would have the number of students. So since I want to find the probability of a student getting more than or equal to 75 marks, I will look down here at the marks and locate 75. And that'll be right here between 70 and 80. And I'll draw a line straight up to touch the curve, and then I'll draw a line straight across. Now, since we wanted more than or equal to 75, that will be on this side, not this side. So that'll be from 75 and above, which means we're looking at where this line touches the y-axis, which is 81, 82, 83. So 83 and above. So I'll just put here is 75, and here is 83. So what does this 83 being here means? So under here being from 0 to 83 means 82 students got under 75 marks. And from the 83rd student to the 100th student got 75 and above. So if we say 100 take away 83, we get 17 students. So 17 students got 75 marks and above. So my sample space, the number of total possible outcomes, NS would be 100 students. And that's because my last frequency for my cumulative frequency was 100, or if you add up all the frequencies, sigma F, you will get 100. And then the number of students with marks greater than or equal to 75 is equal to 100 take away 83, which is equal to 17 students. So what I can write is the probability of the marks being greater than or equal to 75 is equal to the number of students with marks greater than or equal to 75, which I could simply put number of marks greater than or equal to 75 over the number of elements in my sample space, which is my total possible outcomes, which is the total number of students. So the number of marks that's greater than or equal to 75 is 17. And my total number of students is 100. So I can leave it as that, 17 over 100, because you can't break down that, or I can write that as a decimal. So I simply put 17 divided by 100, press equal, convert it to a decimal, and get 0.17. So that's equal to 0.17. And that will bring us to the end of this video.